Hi everybody, this is a video for my 40S Pre-Cal students. This is lesson 4.3, determining exact values, and then later on we're going to be determining approximate values. But basically this is us solving for the values of angles, and then later on being given the values and figuring out the angles by going backwards. So the first section here, the key word here is exact. As soon as you see the word exact, you should know that what's happening is they want you to come up with a number that's either a proper fraction or it's a fraction with a radical in it. They don't want a decimal. They don't want you to touch your calculator especially. So exact is kind of the shortcut for non-calculator. So that means you're going to be using the unit circle. Now, we've done a couple of unit circles in class. We also had the one just like 2 pages ago in your booklet, which you could be referring to if you wanted to. But I'm going to actually ask you to maybe try to not look at the unit circle when you do these questions, because remember on the test we don't give you a unit circle. You have to be able to generate one. And I don't think it's a good plan on a test to sit down and put, you know, all 50 pieces of information that a unit circle might have. I would just start by making a very just rough unit circle and put the 3 important starting numbers on it. You know, you can put, of course, your 1, 0 if you want, and your 0, 1, and then just get the coordinates for these ones. And remember that the coordinates here are, this is root 3 over 2, this is 1/2, this is root 2 over 2 and root 2 over 2, and this one's 1/2 root 3 over 2, and then maybe put the angles on that. So if I'm in degrees, this is 30 degrees, sorry, this is 60 degrees, this is 45 degrees, this is 30 degrees, and if I'm in radians, this is pi by 6, this is pi by 4, and this is pi by 3. And that's really everything else in the unit circle. You can just figure out from those 3. These are the only 3 you really need. And sitting there and filling out a whole unit circle for 15 minutes and then I'll start my test is a waste of time. So I'm just going to basically use that as my template. Okay, that's what I'm going to refer to as I do all these questions. So the first one I can just read right off of here. The cosine of pi by 3 is, of course, 1/2. So there, that one's pretty simple. I can read it right off of here. This one I'm going to have to think about. Secant is 1 over cosine. So I need the reciprocal of the number I just had, which is 2, right? If you need a little scrap work on that, think of that as 1 over 1/2. And then, of course, how do you divide by fractions? You multiply by the reciprocal. So hopefully you're good enough at reciprocaling to just realize that you're just flipping it over. All right, sine of negative 5 pi by 6. So again, I'm going to go to my kind of template here. And I'm going to start thinking backwards by, okay, so 5 pi by 6 would normally be over here, but I'm going backwards, so it's down here. So it's down here, and that spot there would have, I don't even really care what that is. It is actually 7 pi by 6 if I'm going that way, but I don't really care about that. All I really care about is what's its sine value. So going in the negative direction for 5 pi by 6, 5/6 of pi, 1/6 away from being right here at negative pi, I'm going to have the same coordinates as this one, only both x and y are going to be negative. Sine, it wants the sine value. Sine is the y value, so it's going to be negative 1/2. Okay? Cosine of 7 pi by 4. Okay, so where's 7 pi by 4? Well, there's 1 pi by 4. That would be 3 pi by 4, 4 pi by 4, 5, 6, 7 pi by 4 is over here. And that's going to have the same coordinates as this, but the y coordinate will be negative, but I don't care. I want the x coordinate, so that's just going to be root 2 over 2. Okay. Now, cotangent of 270. 270 is down here, and the coordinates there are 0 and negative 1. And cotangent, tangent is y over x, so cotangent is x over y. So that's 0 over negative 1, which is just 0. Okay, cosecant of 2 pi by 3, that's 1 over the sine of 2 pi by 3. And so 2 pi by 3 is over here, right? There's 1/3, 2/3, so it's the same coordinates as this. It's in the pi by 3 family. It's the same coordinates as this, except x is going to be negative. So that's negative 1/2 root 3 over 2. Oops, I already put a comma there. And let's see, which one of those numbers do I want? Well, I want sine. Which one is sine? Sine is the y value. So this is going to be 1 over root 3 over 2. I'm fairly happy with this as a final answer, but of course a textbook or maybe even the answer key in your worksheet might not give that as the answer. They might rationalize the denominator, like so, by multiplying by root 3 over 3. This is something you did in grade 10 and grade 11 pre-cal. So that should be 2 root 3 over 3. I'm happy with this answer, but if you see that one, hopefully you understand that that's the same answer either way. All right, tangent of 11 pi by 4. Okay, now this one's interesting. 11 pi by 4 is past 2 pi, right? 2 pi would be 8 pi by 4. So 11 pi by 4. So I'm actually thinking to myself, 11 pi by 4 minus 8 pi by 4 is actually 3 pi by 4. So I've gone all the way around and then another 3 pi by 4. So that's 1, 2, right there, 3 pi by 4. So what do I know about 3 pi by 4? It's the same coordinates as pi by 4, but the x is negative, and so that means that the y divided by the x will be this number divided by itself, so that's going to be negative 1. And finally, secant of 5 pi. That's like saying 1 over the cosine of 5 pi. Once again, that's more than once around. So this is pi right here. So if I go from here to here, that's 1 pi, 2 pi's, 3 pi's, 4 pi's. Notice all of the odd number pi's land right there. So if you go around once, there's 1 pi, 2 pi's, 3 pi's, 4 pi's, 5 pi's. But I can kind of tell if they ask me for 1,001 pi's, I don't have to count all the way around. I realize all the odd ones end over there. So the point here is negative 1, 0. I want the cosine, right? That's negative 1. And so that's going to be 1 over negative 1. And the reciprocal of that is just negative 1. Now, before we move on to the next section, you can, of course, we wouldn't let you do this on a test, but you can, if you're just doing your homework and you want to make sure, say, you don't have access to the answer key for some reason, you can check these on a calculator. Like, for example, let's do secant of pi by 3. Okay, do you remember on your calculator, we did this in class the other day, remember how to get to radians? On this calculator, it's this DRG button. So I hit that, and now I'm in degrees, and I want to go to radians. So there, now I'm in radians. So let's use my calculator to get the secant of pi by 3. So that's, now there is no secant button on your calculator. So you have to actually go 1 divided by, and then the cosine. Now on this calculator, I have to open a bracket to go pi divided by 3. So then pi is its own button, pi divided by 3, close brackets, and equals. And notice I get the answer I'm expecting. Okay. Next, let's pick one that involves a negative. This should work too. Let's see. We can go the sine of, open a bracket. Remember, your negative button is not, let me move it down a bit. Your negative button is not your subtract button on most calculators. Most calculators, those are different. One's an operation and one's a sign. I want the sign this time, so I'm hitting the negative button of 5 pi divided by 6. Now I close the bracket. That tells me that, notice it actually opened a bracket around my negative, which was nice of them, but there's the bracket I opened, there's the bracket I closed, and hit equals, and there it is, negative 0.5. Now the ones that have radicals in them, you kind of, the drawback to a calculator is, of course, you have to know what those radicals are as decimals. So say I was doing this one, I actually kind of have to know that, oh yeah, that's actually 0.707. So when I go cosine of, open a bracket, 7 pi divided by 4, close brackets, I have to remember, oh yeah, that is root 2 over 2. By the way, you'll notice that I didn't hit a times between 7 and pi. On this calculator, that's fine. On some calculators, that's not fine. And you'll see that it'll even say error because you just put two symbols together and it didn't know what to do with them. So you might have to hit a times button. Just to show you on this calculator is pretty cool, actually. If you have one of these fancier Casios, they're a little more work, but they can give you kind of more exact answers. Like, for example, I'll do this cosecant one down here. So 1 divided by, I have to punch it in this way because again there's no cosecant button on the calculator. The sine of, and it opens a bracket for me, and I'm going to go, let's see, that's 2. Now pi is a little tougher to get to on this calculator. It's actually shift of the scientific notation button way down here. So I have to go shift pi divided by 3, close brackets, and check out what it gives me for an answer here. Oh, actually, I wasn't expecting that. I was expecting it to give me... Oh, wait a minute. Haha, I'm not in degrees. Okay, that's a good... It's actually good that happened. I can show you if you forgot how to do this, how to get to degrees. You have to go shift setup, and degrees is number 3, and I want radians, which is number 4. So there. Now I'm in radians. There, I can see the little R now. So let me punch that again. 1 divided by the sine of 2 pi divided by 3, close brackets, equals, and check that out. Isn't that interesting? This calculator actually gives me that fancy textbook solution I was looking for. If you were actually in a situation where you didn't want this and you wanted a decimal answer, on this calculator there's a button that goes SD, standard to decimal. So decimal, standard, decimal, standard. So that's how you'd work that calculator. And when you of course want to get back to just good old degrees, you go shift setup and go back to number 3, which just puts you back in degrees. It is your responsibility to know which mode your calculator is in when you are calculating. So now the reason that we were playing with our calculators is because notice what example 2 is all about. Example 2 says determine the approximate values. That again is kind of shorthand for saying, yeah, we're going to use a calculator for that. Now let's usually it tells you where to round, so I'll just tell you, how about we round to 4 decimal places. That way, with lots of decimal places, we know we actually punched buttons and we didn't fluke it. We know that we've got the right answer. So tan of 100. So like I was saying a second ago, make sure you're back into degrees. I'm in radians right now. That's clearly degrees. So go back to degrees, and that's pretty easy. You just go tangent of 100. There you go. That's the easiest mark you'd ever get from me on a quiz. I don't think I'd even put one like that on the quiz, but there you go. That's negative 5.6. We said 4 decimal places, right? So negative 5.671. Okay, so 6712. So I'm rounding at the 2 place, and the thing after it's an 8, so it's 6713. Yes, at the university level especially, if you round it wrong, you get 0. So make sure you round properly. Okay, secant of negative 70 degrees. Now, again, there's no such thing as secant on my calculator, so I'm going to have to go 1 over cos of negative 70. And let's do that. So that's 1 divided by the cosine of, and I'm going to open a bracket here, negative 70. And again, remember I hit my negative button, not my subtract button, because it wants a negative, not a subtract, and equals. And I get 2.9238, the thing after the 8's a 0, so 9238. 2.9238. And very often I'll get people ask, well, wait a minute, what do these have units? What units are they? And actually, no, they don't. These are not in units. These don't have units. This is a ratio, right? Think about it. What's tangent again? Oh yeah, it's the opposite divided by hypotenuse. So if those two things were measured in, say, inches or feet or meters or centimeters, in a ratio, if I have, opposite is 10 meters and the adjacent is 15 meters, the meters cancel, right? This is unitless. Those of you who have taken some physics know that that's called a scalar, not a vector. It is a scalar quality. It has no units. So don't tell me that's in meters or centimeters. I'd actually have to mark that wrong. That would be a unit error. Speaking of units, how do I know if that's degrees? It's not degrees because it doesn't have a degree symbol. I think we talked about this in class. Angles, actually the default measurement system in math once you get past grade 11 is actually radians. If you don't see a symbol, you know it's in radians. So now I got to go back to my calculator and get back to radians. So remember, I go here, radians, R80, and I just go the sine of 3.8. So again, that's an easy one. You just have to know what it's asking you. And that's a negative 0.6119. And if you're having a hard time getting these numbers, message me and we'll figure it out together. You're just not using your calculator properly. All right, cosecant of 8 pi over 5. Again, that's not on my unit circle. We don't do fifths of pi in the unit circle, so that's going to be 1 over the sine of 8 pi divided by 5. And I'm going to punch that. Actually, I'm going to show you a different way to punch that. I could go 1 divided. There's actually a button that just reciprocals your answer on every calculator. It's right here. Can you see that? It's x to the negative 1. So instead of just dividing 1 by that, I'm going to try the other button. So it's the sine of 8 pi divided by 5, and close my bracket, and then get an answer. And then I am just going to take my answer and take it to this reciprocal. Take it to the power of negative 1. And there we go. Negative 1.0515. Okay. And that's examples 1 and 2. Moving on to example 3. These are fun. All right, so we're actually going to do some arithmetic with these numbers now. This is a subtract problem, so I'm going to have to think about what the cosine of 120 is. Back to my unit circle. 120 degrees is, well, if this one's 60, that one's 120. And the cosine at 120 is negative 1/2. So this is negative 1/2 minus, and the tangent of 135. So let's see, where's 135? Tangent of 135, that's 45, that's 90, there's 1. That'd be it right there, and that's going to be the same as this. It's the 2 root 2 and 2 root 2, but when I divide them, the x one's going to be negative, so it'll be negative 1. And be careful with your negatives there. So that is going to be, of course, negative 1/2 minus, oh, wait a minute. Oh, I just realized I misread this. I missed this negative. Oh, that might not be a negative 1. Let's go back to here. Negative 135 degrees starts here and goes that way. Aha, in this quadrant, remember the cast rule? C-A-S-T. Tangent's positive here because both of these coordinates are negative. Good thing I caught that. So that's actually going to be a positive 1 in there. So this is negative 1/2 minus 1. Let me get rid of the extra bracket there. That's kind of a waste of space. So negative 1/2 minus 1, and that's like saying negative 1/2 minus 2/2, which is negative 3/2. Okay? And actually, again, I would definitely say that, again, the word exact pops up in my instructions, so this is not a calculator question. But if I was doing my homework and I wasn't sure if I was doing it right, my calculator should do this. Okay, first of all, make sure we're in degrees. Are we in degrees? No, we're in radians. So let's see. So that's the cosine of 120 minus the tangent of, open a bracket, negative 135, close brackets, equals, and there we go, negative 1.5, which is negative 3/2. Okay, I don't think we've had this conversation yet. This is a good place to have it. What the heck does that mean? Well, actually, think about this. If I wanted to take the sine of an angle, let's say the sine of 30 degrees, and I wanted to square it, well, I could put it in a bracket like that. I could say the sine of 30 degrees squared. But if I wanted to be able to write that symbolically without extra brackets, notice that this is kind of ambiguous. It's like, well, do you mean the sine of 30, which is 1/2, squared, which would then be 1/2 squared is 1/4? Actually, this isn't saying that. I would assume this means the sine of 30 squared, which would be like saying the sine of 900 degrees. And the sine of 900 degrees, you know what? 180 goes into 900, so that would be actually 0. So obviously, what does my calculator do if I actually punch in sine of 30 squared just like this? Does it think I mean I want the sine of 30 first and then squared? Or does it think that I want to square the number 30 first and then find the sine of 900? Where does BEDMAS actually land on a calculator like this? I honestly don't know, now that I think about it. Sine of 30 squared equals. Aha! They thought I meant the sine of 900. So on a calculator, I'm probably going to have to actually open up a bracket and go sine of 30, close my bracket, and squared, if that's what I mean. Yep, there it is, 1/4. So what does this weird symbol mean? Actually, it means this. So this thing here is like saying sine squared 30. It allows you to write this without having to write down the brackets and without getting it confused with just squaring the angle. It's actually the square of the sine of the angle. So that's a shortcut that you're going to see pretty much everywhere in textbooks for the rest of your trig careers. So basically this is the sine of 7 pi by 6. Back to my unit circle. Where's 7 pi by 6? That's 1 pi by 6 past pi. So what is the sine value here? I guess I don't have the coordinates there. This is in this pi by 6 family. So it's negative root 3 over 2, negative 1/2. So the sine value is negative 1/2, but it's a negative 1/2 being squared. Cosine would be the x value, which is the negative root 3 over 2 being squared, and that is 1/4 plus 3/4, which is 1. And that, by the way, is an identity. We actually already kind of know that the sine squared of an angle plus the cos squared of an angle equals 1, because that's actually just Pythagoras. A squared plus b squared equals c squared. Remember, though, that the c, the diagonal, is, of course, the radius on the unit circle, which is 1. So kind of knew that one was going to turn out that way. The rest of them on this page, we don't really know how they're going to turn out. Okay, where is negative 3 pi by 4? So that's going to be, starting here going backwards, that's going to be over here. Right, that's 1 pi by 4, 2 pi by 4, negative 3 pi by 4. The tangent there is positive 1. So the cotangent, the reciprocal of 1, is still 1. And the cosecant of pi by 2, here's pi by 2 up here. And cosecant is, of course, 1 over the sine value, which is also 1. So that's basically the reciprocal of 1, which is itself. So that one is 2. And down here, the tangent of negative pi by 3. Okay, well, pi by 3 negative is going to be that way. That's going to be this angle here, which is the x is positive and the y is negative. So the tangent value at negative pi by 3 will be negative. Remember, the y goes on top. Oh, I'm off the screen. I'm sorry. Remember that the y goes on top. So that's negative 3 pi by 2, or negative root 3 over 2 divided by 1/2. So that's going to be negative root 3, but I'm squaring it. This one's a times the secant of 4 pi by 3. Okay, so that's, I'm going to say that's, of course, why don't I just rewrite this? This is like saying tan squared of negative pi by 3 times 1 over the cosine of 4 pi by 3. So this is times 1 over, and what's the cosine of 4 pi by 3? Well, 4 pi by 3, oh, my hand froze. There we go. The cosine of 4 pi by 3, that's 1/3 past, so that's 1, 2, so that's here. That's this family, so that would be negative 1/2, negative root 3 over 2. Okay, which one do I want? I want cosine, that's this one. So that's 1 divided by negative 1/2. Okay, so that's going to be, and am I squaring the secant one? No, I'm not squaring the secant one. So that's going to be, well, the square root of 3 squared, and the negative is being squared as well. Make sure you understand that I'm squaring every part of this. I'm squaring every part of that value. That negative is part of this value. It's getting squared. So that's going to be root 3 times 1 divided by negative 1/2, which is negative 2, and that's going to be negative 2 root 3. And again, you could punch that through in your calculator to check it. It's kind of a complicated button punch. It's probably less work to actually do the problem the way I just did. But let's see if we could do it. Let's see. First of all, are we in radians? Nope, we're in degrees. So let's get to radians again. Radians, there we go. And let's see. So we want the tangent. Actually, I'm going to open a bracket. We want the tangent of, open another bracket, negative pi by 3. Close the bracket for the angle, close the bracket for the tangent, and square it, times secant I can't do, so that's 1 over the cosine of, open a bracket, 4 pi by 3, close the bracket, and hit equals, and there it is. Negative, oh, whoops, I made a mistake. Oh. Can you see that? When you square a radical, the radical goes away. You guys probably noticed that. You were shouting at the screen like it was a horror movie in a theater. Don't go in there! The killer's got a knife! There we go. Sorry about that. Good thing I checked that one. If this was me doing my homework without cheating, I'd have checked the answer in the back and realized, hey, wait a minute, something went wrong. That's what went wrong. I squared the radical and I forgot to get rid of the radical. Well, that's 2 mistakes so far. I really should start making these videos earlier in the day when I'm sharper. Anyway, now let's do this backwards. Now that we've seen how to solve questions like this, where I ask you to find the cosine of an angle, the sine, the inverse, or the secant, the cosecant, the cotangent, what if I give you the ratio and then ask you to figure out what the angle was that made it? And I'm going to give you a range. Theta can be anywhere from between 0 and 2 pi. Okay, these are all kinds of fun. I like these. So the way that you do this is, you remember that you find your theta little r. Do you remember what that stands for from grade 11? It stands for your reference angle. Need a quick refresher on what a reference angle is? Think back again to back in grade 11 when you learned that you always measure the closest angle you can get to the x-axis as your reference angle. So in quadrant 1, all angles are their own reference angle. So if that's 30, the reference angle is 30. But if I had, say, for example, a 150 degree angle, which looks like that, its reference angle is 30 degrees because it's only 30 degrees to get from your terminal arm back to your x-axis. So what's the reference angle for something like, oh, I don't know. What would the reference angle, let's switch to radians, be for, I don't know, let's say 7 pi by 8. Well, let's see. Well, that would be right about here, and then this extra, so this would be 7 pi by 8, and then this would be 1 pi by 8. Notice that's not even on the unit circle, but I know that from here to here has to be pi. What if I had something like, let's say 11 pi by 5 is my angle. What's my reference angle? Well, 10 pi by 5 would be all the way around, so that's 1 pi by 5 as a reference angle. So reference angle is the closest angle to the x-axis. So that's what we're going to find. That's clearly not on my unit circle. That's none of the decimals that I have remembered from the unit circle. Plus, yeah, that's it. I know that that's not root 2 or root 2 over 2, which is 0.707. I know it's not root 3 over 2, which is it's close. It's 0.8, but it's not 0.879. So I'm going to, first of all, solve in the right thing. What kind of angle do we want? We want an angle in radians, because this says 2 pi. So I'm going to go up to my calculator and get back to radians. Oh, I already am. Good. And then I'm going to find the reference angle. So theta r is the reference angle. So inverse sine of 0.879 is 1.0738. Okay? And remember, don't put degrees on that. Radians, these are radians. You don't need a degree symbol because it's not in degrees, it's in radians. And you don't need a little r for radians. We just know that's radians. But that's not the only answer. That answer, that reference angle, happens when sine is positive. And sine is positive in 2 quadrants, here and here. So that 1.0 can happen here, but it could also happen here. And you're probably wondering, well, how do I figure out how big that angle is? Well, remember, all the way to here would be pi, right? So starting here and going all the way to there would be pi. So this angle here would be pi minus 1.0738. Or, I mean, I already have the number on my screen, so I'll just go pi, where are you, pi? Pi minus my answer. And that's 2.0678. And that's my 2 answers. Therefore, theta can be the angle. Remember, in quadrant 1, angles are their own reference angle, 1.0738. And my other answer is 2.0678. And yes, you have to give both answers, or you're not right. Okay, this reference angle stuff is especially important when you have negatives, because calculators don't always handle inverse cosine, inverse sine, and inverse tan of negatives properly. So step one is drop the negative, I'll write this in words, to find the reference angle. Okay, so notice that this one's back in degrees, so I'm going to go back to my calculator and switch back to degrees, and then I'm going to find my reference angle. So the theta will equal, theta r, my reference angle, will be the inverse cos of 0.366, right? I've dropped the negative. Don't punch buttons with the negative when you're doing inverse trig functions. Second function cosine of 0.366. And it's telling me that that is 68.53 degrees. Now, where is that? Let's see. Let's make a little sketch. Cosine is negative in two different places, here and here. So that's a 68.5 degree angle there, and a 68 point, whoops, put the decimal in the wrong place, 68.5 degree angle there. But I need to know how big that is and how big that is. Okay, right? It says I have to find all the angles between 0 and 360. So one of them is going to get me to here, and the next one's going to get me to there. So the first one would be 180 minus this angle. So 180 minus my answer, and that's 111.4691 degrees. And my second answer would be actually 180 plus that angle. So why don't I just take that answer and minus 180 again, so get back to my original answer, and then actually just times it by -1, get rid of the negative, there we go. So take my original answer, and then on this bigger angle here, right, I have to add it to 180. So plus 180. And 248.5309. 238, so sorry, 248, sorry, I can't read, 0.5309 degrees. And that is my two answers, 248.5309, yep. So there's my two answers. And you can check that this is right. If I take the cosine of this, I better get negative 0.366. So let's see if that's true. The cosine of my answer is, yep, exactly. Cool. Okay. Back to radians. Oh, that's, there we go, radians. So I don't know if I don't need a calculator for this actually, now that I think about it. That one's on my unit circle, no calc. No calculator. That one's on the unit circle. So where is sine 1/2? So again, what is my reference angle? Sine is 1/2 here at pi by 6, and then here at, that would be, the reference angle is pi by 6, but that would be then 5 pi by 6, right? So pi by 6 and 5 pi by 6 are the two places where it's, oh, that's the two places where it's positive. Where is it negative? So theta, the reference angle is pi by 6, but I want, sorry, I forgot where I wanted. I wanted the two places that are negative. So I want that one down there and that one down there. So this would be 11 pi by 6, and this would be 7 pi by 6. So that's my two answers. So x is 7 pi by 6 and 11 pi by 6. And again, you could double check, you could, if you wanted to. This one also, actually all the rest of these are on the unit circle. No calculators from C on down. So everything on the bottom of this page now, sorry, you're out. All right, where is cosine? That's one I don't know that I need to worry about reference angle. I think I can tell pretty easily where the cosine is -1. Cosine is -1 right here, right? -1, which happens at 180 degrees. So D is just 180 degrees. That's it. That one was easy after the last one. All right. Who remembers where tangent is √3? Here's what I remember. I remember that tangent is y over x. So which one has the sine value where √3 is on the top? And that's in the 60 degree family. So my reference angle is 60 degrees. Okay? But look at this one. I'm going to draw this. A good thing this one was short. I got more room to draw now. This one, I am looking for angles from 0 to 180 and then from 0 to negative 180. I'll do this in 2 different colors. Maybe that'll help. So I'll do this one in red, and I'll do this one in whatever that is, black or blue or whatever color I'm using here. So let's see. From 0 to 180, when do I hit 60 degrees where tangent is positive? Well, actually, tangent is only positive in quadrant here and here. And if I'm only going from 0 to 180, I won't get to this quadrant. So the only answer I have is the 60-degree answer. So theta is 60 degrees. I don't make it to the answer I would have got here if this had said go up to 360 degrees. Okay? Now, what if I'm going backwards? Well, if I'm going backwards, I'm definitely going to hit this reference angle of 60 because I'm hitting it going from 0 to negative 180. So I'm hitting it going that way. What is that angle? Well, let's see. It'd be 60, 90. That'd be negative 120 degrees. And this one, you know what? Just to make sure I did this one right, I think I will check this one. According to my calculator, tangent of negative 120 should be root 3. And I got to do that back in degrees. So the tangent of 120, is that the same as negative root 3? Let's see, what's the root of 3? You bet it is. So we got it. And that's the only two answers. It's like, oh, wait a minute, wouldn't tangent also be negative here? Yeah, but I can't get to there because I stop at negative 180. So be careful with those. This next one has the same kind of trick to it. Where is secant theta equal to 2 over root 3? Well, first of all, I don't know nothing about secants, but I do know that the reciprocal of this is cosine, and the reciprocal of this is root 3 over 2. If you have an equation where there's no pluses or minuses, it's just ratio equals ratio, you can just flip them both over. You can reciprocal both sides of an equation. Now, where is cosine root 3 over 2? Well, the reference angle for that, cosine is root 3 over 2 at pi by 6. If you think back again, go back to my sketched unit circle. Yep, at pi by 6, the cosine is root 3 over 2. So that's where that is. But now I'm searching for answers from theta has to be less than or equal to pi. So I can only go from 0 to pi this way, so in there, but then I got to go from 0 to negative 2 pi this way. So let's do the black one first. Where do I hit the pi by 6 family? Where cosine is positive? At pi by 6. Okay, so pi by 6 is one of my answers. That's the only place I'm going to hit that answer because cosine is going to be positive here again, but I won't make it to there because I have to stop that way. But I will hit it going this way. Remember, that's a pi by 6 that way. And if I'm going this way, that would be negative pi by 6. But I would also hit this one going this way. And if I did another pi by 6, I'd make it all the way to 2 pi, which is 12 pi by 6. So this one is negative 11 pi by 6. So there's 3 answers for that one. Cool beans. So that's how you do questions like those. And they take practice. They take being careful. Yeah, cool. Check out your homework, everybody. That's it for today.